Let's see. Let's listen to this talk and see if we can come up with some ideas. So put your hands together for Rahul Thakoor.
So hello everyone. Thank you for being here. It's been a long day and a lot of great technical talks, and this one's going to be a bit different. So I titled it "Bringing More People Closer to the Matter." The idea behind it is, like, the TLDR of it is a lot of people are getting interested into physical computing, embedded programming, stuff like that, but they are not mostly from the technical background. And I'm going to also share my own journey about how I got into Rust, into embedded programming, and into programming itself, and how I'm helping people who had similar problems as I got into this realm of programming, and perhaps inspire you to help others in a similar way. So before I introduce myself, first let me get a feel of the room. Is anyone like doing embedded stuff but is not from a technical background? Perhaps. I know there was another person, so there she is. So yeah, we are quite not that a lot in the community, but trust me, based on my experience, there are a lot of people coming from a non-technical background into embedded systems. So yeah, my name is Rahul, and I come from Mauritius. If you don't know the country, don't feel bad. I have a slide like showing you where on the world map. So anyway, and I participated in Increasing Rust Reach last year. For those of you who don't know, it's a mentorship program by Mozilla for people who are underrepresented in tech, and it was a great experience. It kind of like confirmed my love for the Rust community. So yeah. And I'm also working on a project called Rust GPIO 0, which is a port of a Python library that allows you to get started with the Raspberry Pi and Python. So I'm going to do that for Rust. It's actually, I've released 2 versions for now because I'm a student and it's kind of hard to find sometimes doing Rust as a hobby. And I'm also developing a learning guide to accompany this crate, which is called Rust GPIO 0. And the guide is called Physical Computing with Rust. And perhaps Jonathan has had some experience with it. I don't know. Anyway, so yeah, like I mentioned, this is where my country is. It's so small that the logo covers it. So anyway, I'm going to start with this observation. This is from a book called Physical Computing. So what the authors they teach physical computing at the New York University, the School of Arts. And what they've noticed is like a lot of people from diverse backgrounds are getting interested into bridging this gap between the virtual and physical. So it might be a teacher who is trying to use Raspberry Pi to make their classes more interesting, perhaps teach STEM programming, or STEM concepts like, I don't know, teach physics through Raspberry Pi. Or it might be an artist who wants to make their painting more interactive, add LEDs, or whatever reason. Or perhaps it's also a software developer who wants to change domain or do some embedded stuff just for the fun of it. And like we've seen with the skateboard, embedded programming can be very fun, but it is also very daunting getting started. And I know this firsthand. I'm going to share with you how in a while. But at the heart of this is a lot of people have been trying to understand how this has come from. And for me, I think it's because of the maker movement. So if you've heard of it, this is like, oh, what powers this, like the maker culture. So now we see a lot of people trying to do DIY projects. They are doing, I don't know, bridging different domains. People doing, so it might be someone a farmer who just wants to bootstrap a system to get data from the sensors or whatever. But at the heart of it, it's like there are different intersections of different fields, and a lot of people are trying to get that working. It's not only related to software. It involves craft with wood, metal, a lot of stuff. So this is the gist of it. So these people somehow, if it's a carpenter somehow wants to add a microcontroller on their project, perhaps you're going to have an encounter with them if they're using your library, or if they're using any tools that you've developed. So I can't speak for all of those people, but I can share my journey with you. So I also come from a non-technical background. I've always been interested in programming, but life happens, and I ended up studying medicine in China. So it's a long story. I won't have time to share that with you. If you want to talk afterwards, we can do that. But anyway, while I was studying medicine, I also tried coding. So I tried the traditional way. I tried a lot of MOOCs, massive online, open online courses, Coursera, Udacity, you name it, I've tried it. I have like pending courses everywhere. So yeah, the traditional way has failed me. I tried Java, I tried C, I tried JavaScript, kind of like was okay. But yeah, I always find myself abandoning like that path to learning programming, and also because I was studying medicine in Mandarin, it was very complicated. So anyway, but then I stumbled upon this project from our university. It's from the biomedical engineering department, and they were using this thing called the Arduino, and they said like, okay, we've programmed this. We are using code, and we are able to write code that controls motors. They were able to take sensor data, and they were actually doing some pretty cool stuff, like gathering biofeedback, gathering EEG data from people. And I said, like, okay, this sounds very cool. And I bought an Arduino, because in China you can get it for very cheap, and it gets delivered the next day to your doorstep. And that was when I got hooked up on this. So while I tried learning from the traditional way of Hello World, to do MVC, to do whatever app, writing a list app, shopping, it failed me. I was kind of hooked up on this one. I was actually writing code that could, you could see the immediate effect. You say blink, and it's actually blinking in front of you. This is what got me hooked on that system. And I thought like, okay, I'm gonna do that. I got a chance to participate in a hackathon by Intel, and that was where I got the opportunity to also work with people from different backgrounds. So we were assigned a group. There was a mathematician, there was an Android developer. I was from a medical background, and we worked on a project that solved a problem in nursing, where you have a device that assisted the nurses to better care for children. So anyway, all of this is interesting, but why should you care? So what's in it for you? I can't say for sure, but I mean, if you're from the Rust community, a lot of people come to Rust because of speed, productivity, memory safety. But for me, it's also mostly because of the Rust community itself, how it is welcoming, how we accept different people, how we are open to helping others. I've had like first-hand experience with people like this. I've gone on Discord asking questions. People are like immediately giving me feedback. And even the Rust programming language, it celebrates this. The slogan for the language has changed over the years. It used to be like being a systems programmer, but now this is like what the Rust lang is all about, empowering everyone to be reliable and efficient software. So you see there's everyone. I think we need to define that everyone. So is everyone only programmers, only developers, system engineers, or whatever? Or is it like it says everyone? Everyone is welcome, be it you're an artist who wants to, I don't know, you're a ballet dancer, you want to to capture your movement with an accelerometer, or you're a teacher, you want to make your classes more interesting, or perhaps you're a medical graduate, you want to get some data from a glucometer. I think this is what the Rust community is all about. And empowering also means making that person like stronger and more confident in being able to do that. Other languages, other communities, I'm not sure. I've tried doing C, a lot of stuff, but I've seen this in the Rust community where we are open to helping others. And you'll see this all across the ecosystem. This is like a quote from the Rust programming language book, which I'm sure most of you have gone through. And if you read the foreword, this is highlighted everywhere. It's like they want to empower people to reach different domains. So even if you're a software developer, you should be comfortable getting into embedded stuff. And even if you're not a software developer, you should be able to do that. And Rust is very interesting because the Rust community, I mean, we are bound to break down the barriers to entry into that point. And if you've seen that, the Rust community has different tools that makes it easy. So seeing a language that favors pedagogy, for instance, there are the working groups books, there's like the discovery book, there are a lot of stuff that is going around because Rust cares about teaching people how to use all of the tools itself. And this is what makes Rust also very interesting for getting people to get started in this journey. So a lot of people say Rust can have a very steep learning curve, but if you're coming from any language, if you're only interested in doing hello world, that's okay, but if you want to get into that language, understand it, there's also a learning curve attached to that. So while I was transitioning into this new realm of programming itself, what were the barriers to entry? So doing embedded stuff is kind of hard because it involves so many different intersections of different disciplines. First, of course, you need to understand some basic electronics. You need to understand sensors, input, outputs, and stuff like that. There's also, you understand like how to program a chip, a microcontroller, attach pins, and stuff like that. But also, you have to be able to program those computers, and that's where it gets interesting. I mean, if you look at the options out there, someone who wants to get started, what are the options? You could do MicroPython, you could do C, you could do Rust. So why not Rust itself? Anyway, so there are also other things that are associated with this. You need to understand how to communicate with different protocols. You need to understand how to gather data from one device and send it to other. So it can be kind of daunting getting started. There's a lot of jargon associated, and it also one of the other barriers to entry is we are talking about computers and different devices, but usually if you come from a very developed country, it's okay. We talk about cheap devices, we talk about stuff like discovery board, but we have to be considerate about the fact that these devices are not accessible everywhere. I mean, I want to do the discovery book, but I can't get the board. And even if I get the board, it's extremely expensive because by the time they cross the borders and customs, you have to pay pretty much money for that. Or simply because those devices are not available in the country. It won't be available anytime soon. So if there are so many hurdles into getting started with programming, and especially with embedded programming, so why bother? Why get started with physical computing itself? This is because, like I mentioned before, computers can be learning instruments. So not everyone gets it, like doing a project, you do a Hello World app, writing to the console, it's fine, but not everyone gets hooked on this. And traditional teaching of programming itself, it is around manipulation of abstract information. So people like you're doing some basic programming, but I believe writing code that can actually interface with the real world is way more engaging for students and for anyone who wants to get started. And this is not a new concept. I don't know if you guys know this author called Seymour Papert. So in his book called Mindstorms, he highlights that computers are the Proteus of machines. Proteus itself is like a Greek god which can take different forms. And I think this highlights what I'm trying to say. It's because computers can be so universal, we can see computers in different shapes and forms now. You have your mobile phones, you have Bluetooth SoCs, you can have a mainframe computer. And because it can have different functions, it can also, and takes different forms, it can appeal to people of different tastes. And that's what makes it interesting. So this is Seymour Papert. If you don't know him, he's like one of the pioneers in the field of artificial intelligence and a proponent of a learning theory called constructionism, where it states like learners mostly people learn by building stuff. So you actually learn by mental models that you create by building and experiencing that kind of story. So let's say you want to help the ecosystem, you want to help people to do that. How should you go about doing it? At the heart of it, it's abstraction. What I mean by abstraction is like you hide away the complexity of the problem in context. So this is very inherent to computer science and programming itself, because like, for instance, assembly language abstracts away the machine code, and programming language themselves abstract away the assembly language. And this happens at different layers. So every time we see recurring patterns, we can just extract that into a new framework. And that's how we can build high-level libraries that can make it easier for people to get into a problem domain without so much caring about the low-level stuff. And for me, this is like I mentioned before, sorry, you can see that the crate I'm developing is called Rust GPIO 0. So essentially, this is how you would do this. So someone getting started with physical computing and embedded stuff, yes, it's okay to go low level, but perhaps when they're trying to wrap their head around basic concepts like input, output, they don't want to know like which pin, PWM, and stuff like that. So abstracting away that kind of information can really help them get into it. So for instance, in the library, you would have different components. So you could have a lead component. And the library provides methods that work like it would in the real world. So when someone thinks about LEDs, they think like it can be turned on, it can be turned off, and it can blink. So without much boilerplate, you're able to do that. And yes, I've managed to do that without blocking the API. So now you can do let.wait so that the program doesn't exit directly. Anyway, that's irrelevant here. But the library also provides other components. So someone, as they are learning, they've interfaced with an LED. They might be interested into interfacing with a motor or a servo motor or PWM LED. So they have this flexibility of doing all of that. And from the feedback I've got from the community, it's like, how do I know this is helping someone? And I've written tutorials, I've gotten a lot of feedback on Twitter, and this is just like one example of them. It's people who are trying to learn Rust and embedded at the same time. They think like being able to have like a high-level abstraction of all the interfaces makes it really easy for them to get started, because while they are getting started, they don't want to go deep into low-level stuff. And this, at the heart of this is just taking a top-down approach to learning and teaching itself. And since we can't do a lot of stuff on our own, and even the library I'm writing is not like all of my work, it's just like standing on the shoulders of giants. So you'll use other libraries, other crates to be able to abstract away. So perhaps there's a library out there, you find it very interesting, you find it very easy to use, but it might not be the case. And someone else can write a wrapper around that or abstract away some of the complexities. And for instance, in Rust GPIO 0, I'm using a crate called PPAL. And as people get more into the concepts around programming into embedded systems, they can experiment with other stuff like embedded Hall. They can do hardware PWM. They can experiment with SPI, I2C. So this is like, in my opinion, if at first you give someone all of those ammunitions, they might get distracted or even confused, and they might just give up like I did in other cases. So that's all great. We can have different high-level libraries. We can have different crates. But I believe this is not enough, because we need to guide people how to use them. So what might come like second nature to you, instantiating, using builder patterns, using this and that, might not be the same for other people. And as you're developing new libraries, you're developing new tools, you have to be considerate about that. Because trust me, there are a lot more people from diverse backgrounds who are getting into the Rust community, and you're definitely going to have an encounter with them. So how do you make sure like the tools that you're providing, you can have like the top-notch crate out there, no allocations, zero copies, zero abstraction. But if someone wants to use them and can't use them, or even don't understand how to use them, it can be very challenging. So now I'm not, you don't have to go and write beginner tutorials for everything, how to do this and that, but at least provide the breadcrumbs, provide a roadmap for something that might be trivial to you, but might not be the case for some other people. And we can see this in a lot of situations. For instance, tutorials tend to be like this. Someone wants to draw an owl, so you start like this, and this is basically the gist of it. And there's a gap in between, and this is where you can help. You can bridge that gap and make it more accommodating for people who don't know how to get from 1 to 2. Perhaps there are several steps involved, 1.1, 1.2. So yes, that's where you can help the community. And this is exactly what I'm trying to do with the crate I'm writing. I'm also a beginner. I'm learning along the way. I don't get to do Rust at work, or I'm still a student. But yeah, and this has been a very interesting project, because as I'm developing the library and encountering different situations, for instance, doing multi-threading and stuff like that, I'm also finding myself having to learn new stuff, and documenting it makes it very interesting. I love the fact that I don't consider myself like a total beginner, and I'm just like, the right time to write a tutorial is like when you're an advanced beginner, like you've just figured stuff out, and when you write it out, it's like it speaks to most people who are trying to figure it in their own way. So because of this, I also enjoy teaching and learning this stuff, because I want to share my experience. There might be a lot of people out there who want to have same way of learning this. And for this, I usually do a lot of workshops and boot camps in my country, where I've taught a lot of workshops in JavaScript. Perhaps you guys know a framework called Jonny5. So it's like, it has been branded as the jQuery of hardware. So you get, it's a framework that gives you a lot of components, server motors, LEDs, similar to the crate I was talking about, but for JavaScript. And it can interface with different devices like Arduinos. It can run on Raspberry Pi also. And last week, I got a very great opportunity to be able to go to Asia and to Beijing, actually. I went back again after 3 years, and there I had the opportunity to do a workshop. So I did a workshop called Getting Started with IoT using Rust and your smartphone. So why I did it that way is based on the feedback I had from the community in my country or other places online. There is one of the other barriers to entry is getting devices, and it might not be able because it might not be because people can't afford it. It is usually because people find it a big commitment. Buying hardware is a huge task. Which one should I get? Is this one supported by this library or stuff like that? And getting your sensors, you can say like buying the board itself might be $5, but by the time you add a power supply, sensors, and stuff like that, you are pretty deep into, it can be very expensive. So I thought of a different way of teaching this, and that's where I used a Blink. So any one of you knows the Blink app, perhaps? Okay. So this is a very interesting project. It was funded on Kickstarter and actually went overboard for the funding. So what happened is we have an app that can run on Android or iOS, and this app gives you a drag and drop interface for different widgets. So you can have virtual LEDs, you can have widgets that give you access to your sensors on your smartphone, so you're actually retrieving data. So the idea behind the workshop was instead of getting people in buying different boards directly, which can be a huge commitment and challenging, and also I've had workshops where people are still trying to get the drivers for 2 hours and haven't actually learned anything yet. So I tried to bypass this one and use their own laptops as an IoT device, laptops and smartphone as an IoT device. So the Blink ecosystem provides a library that can run on different devices. So one of those libraries is a JavaScript one. There's no Rust library yet. Perhaps you guys are going to do that in the implement days. I don't know. But the cool thing about the JavaScript library is it can emulate a running device in the browser. So your browser, your computer is acting as a device, an IoT device that is going to be recognized in the app itself. So at that point, you can just send sensor data to your computer or send commands from your computer to the app. So this is mostly what IoT is about, taking input, doing output, and processing in between. So I thought it'd be interesting to be able to teach those concepts. Most of the attendees were like complete beginners. They didn't have any, most of them were software developers, but they didn't have any exposure to IoT or embedded stuff. And how I used Rust into that was actually because the Blink server is all open source and it provides a REST API, so we're actually hacking our way into it. So I was using the request crate to be able to do HTTP requests and trigger different devices. So we were able to blink LEDs, we were able to take accelerometer data and stuff like that. And based on the feedback from the workshop, people found it very interesting. So they were, I don't know if you can see it properly there, sorry about that. So they were able to use widgets like get accelerometer data. They were able to send data to their app itself, like hello, all using Rust and the request and HTTP API. They were also able to get GPS coordinates from the sensor on their smartphone. So basically, they could experiment with IoT without actually going and buy some kits. And after that, I asked most of the attendees, so how did you find this workshop? So did it actually inspire you to go and try? So most of them said yes, because they had actually tried doing that before, and because it can be very daunting, and they didn't want to buy stuff, or they didn't know which stuff to buy. So they thought like this approach really helped them get a gist of the basics of IoT, and they were they had a lot of questions about how do I get from here into Rust embedded, which STM board should I buy? It's like they even created a group chat just to be able to exchange ideas based on this. So yeah, that's basically what my journey and my way of trying to help people has been around. So now it's your turn. Perhaps, I don't know if you're inspired enough to be able to, next time you're developing something, be considerate. There are a lot of people who come in from different backgrounds, might be able to use your tools. And like James said this morning, while you're building tools and you're telling your story, it's one of the commandments also is there's like you have to share your story, and you have to be able to accept that different people coming from different backgrounds is not a bad thing, because in my opinion, like innovation happens at the intersection of different ideas and different expertise. And perhaps when you're trying to teach someone else something about your experience and your expertise and your area, you might also be able to learn some things from them. So thank you very much for listening, and I'm good.
All right, a call to action there. Okay, I can see some questions immediately. Okay.
So the question was like if I've considered putting my feedback into the embedded book or the book. Yes, but because I've been on the move for quite a while now, I haven't gotten the chance. But I'm definitely going to share my ideas and the new stuff that I've learned, and perhaps in a blog post, or even share with in the embedded newsletter and stuff like that. I'm definitely going to do that, because there are a lot of stuff that people have said and during the workshops it's worth sharing also. But because I've been doing 3 Rust talks back to back for this is the 3rd one. I've been traveling from my country to China and Turkey and here, so it's been a long 3 weeks. So maybe later.
Yeah, just to add to that, I think there's definitely scope for people can contribute to the book, and experts, people in the working group, whoever, can learn from others, listen to these experiences, and they can help contribute to the book as well. I think that's fair. Any more questions?
The question was like where you can find people who are a bit shy but they still want to learn, and they. I myself, like, I've taken a lot of courage to be able to even attend a local meetup and yet giving a talk at a meetup. So usually you'll find them at meetups, or you'll find them, I don't know, if they're brave enough, they're trying to ask questions online. So be more receptive to. But I think in the Rust community, people, at least we're not that afraid of asking questions, because the community itself is so welcoming. So like that's why I mentioned like this can be so this is why Rust is so good for this kind of experience. And yeah, so for me the formula that is working for the time being is going through the first 3 chapters of the Rust programming language book, the book, like by Steve Klapnik and Carol Goulding, because the book is actually made. It doesn't assume any prior knowledge. It teaches you the basics of programming itself, and once you can do basic stuff like you can understand control and stuff like that, you can get into. If you want to learn through physical computing or embedded devices, you can try the crate that I'm developing. I don't know. Perhaps it'd be easier for you to get a Raspberry Pi. You can also try STM, the blue pill, perhaps. Perhaps we have to develop more beginner-friendly ways of getting into the blue pill. So, yeah, some food for thought for the implement days. For instance, I've tried, I don't know you guys if you know in the embedded whole ecosystem, there are drivers. I tried writing a driver for an accelerometer. Can't remember the code, MMAF something. So it's a 3-axis accelerometer. And going back to like the high level and recurring patterns, I always found myself like, because I consulted so many different drivers, like how other people wrote it, at some point it seemed like we could even have a boilerplate for different drivers. So explaining why it is that way, and so even someone who's a complete beginner can learn by writing a driver, because I actually learned how to look into data sheet, how to do bit accessing and stuff like that by actually writing that driver. So yeah, there's definitely room for a lot of different learning material.